Okay, so we're going to start going over the lesson 6.
Yes. Oh, whoops. Let me see. Okay. Perfect. Okay, I've got it.
Okay, so number 1 was, what is the sampling distribution? Which
I said,
go ahead.
oh, go ahead.
As a set of all possible values of the sample mean that could occur.
That's what I had to. And then what is the shape of the sampling distribution of the sample mean when the data is normally distributed? And I said normal.
Mm-hmm.
Is that what you put?
Yeah. And then the shape of the distribution of the sample means when the data are not normally distributed, but the sample size is large, and I put approximately normal.
Cool. Okay, how does the shape of the distribution of sample means change when the sample size is increased? So the sampling distribution more closely approaches a normal distribution, and the standard deviation decreases, the mean is unchanged.
Right. And the difference between the central limit theorem of large numbers is that the central limit theorem is that the sample mean will be approximately normally distributed if the sample size is large, whereas the law of large numbers is that as the sample size increases, the standard deviation decreases.
Cool. When is X normally distributed? And I said it's when the sample size is large, but I don't know if that was correct.
There's two. So when the parent population is normal, and then when the parent population is not normal, but the sample size is large enough.
Oh, okay.
So it's those two things.
Okay. This next part, I don't know. I didn't do all of it because I didn't know if I was doing it right or not. I'm telling you, math confuses me so bad. But I did, so I like the random.org generator.
Mm-hmm. Yeah.
I got 5 of them. And so to find the mean, right, you add all of them up. So all the 5 up, and then you divide it by 5.
Right.
So the number I got was 185,620. But then the next question, like mark, where you'd be at. But my number is so much bigger than any of these numbers.
Mm-hmm. Did you divide it by 5 after you added it all up?
Yeah, I thought I did. I don't know. I did it a couple times, and I was like, this is not working the way it's supposed to. It's 45,000 plus, I had like 1 and 29 and 24. They're all, all of these are big numbers. So that's why I was like, I did something wrong here.
Yeah.
But
yeah, because mine ended up being 51,640.
Okay. I must have added them wrong or something.
Mm-hmm.
And then maybe I did divide them by 5, but
yeah,
I must have added them wrong. Yeah.
You should be
That's okay.
somewhere in the.
Yeah, that's why I was like, I know I did something wrong because I can't mark it anywhere. Let me see, because I did. Okay. Let me add all these up.
I
had 45,000. Then I had 25, which is 45,000 again. 15, 40,200. 29, 45,000. And 24, 52,5. Yeah, 185,620. I don't know what I'm doing wrong.
Okay, so what was the numbers you had again?
I had 25, so 45,000.
And what number?
Then 15, 40,200. And then I had 29, 45,000. And then I had 24. And then I had 1.
Yeah, I get 45,460.
What am I doing wrong? Are you doing it on your, I did it on my phone calculator, but I don't know. Maybe I need to add them and, let me see. Okay, 227, 300. Oh my goodness, you know what I was doing wrong? I know what I was doing wrong now. It's that I was doing it all on the same thing on my phone.
Oh.
And I wasn't separating, you know what I mean? I was adding them and I was dividing the last one by 5.
Oh, right, yeah.
I thought that it would just divide everything. I don't know why. Okay, well then that makes sense.
Yeah, yeah.
Okay then. Well, there we go then.
And
Okay.
so then the next question was to put it, like, mark it on that graph.
Mm-hmm.
And then does your sample mean appear to be unusual or usual? Or yeah. And yours,
Mine would be pretty close to the middle.
right. But
So
mine,
that'd be
right. But mine isn't.
okay. Because yours was like on the right side.
Yeah,
Right?
right.
Okay.
But I didn't understand why. Because it seems like if this is a normal distribution, and the sample means are large enough, then we should be able to pick 5 and have our
Yeah.
A and B close to the,
Close to the middle.
yeah, close to the, all the other means.
Yeah, that is odd. But you must have gotten a bunch of high numbers in yours, like all of the ones that were up in the, like even like 21 and 22, 21, 22 are almost 60,000.
Right, and I had 5, 14, 19, 17, 3, and 29 in my numbers.
Okay, yeah. Yeah.
So
I don't know. Funny.
Yeah,
But I guess some of them have to be, you know, I mean that the distribution goes from 40,000 to 50, like 53,000.
hmm,
You know, there's got to be some of the numbers are going to be there, you know.
right.
So, yeah. So then for G, just compare your mean. What I took this as that we're supposed to compare it with each other.
Right,
Are we
yeah.
supposed to, or are we supposed to do? Oh, okay.
That's what I would think.
Um,
So if Bryce was here, we could have seen what he'd gotten to and see if, like, if we were all over the board or if we were all similar or
yeah.
what would happen.
Well, it looks like we're. I mean, what was your mean? What was the number you got?
Mine was 51,640.
Yeah, so you were still in the curve. You weren't out of it. So I mean, I guess it's pretty. Ours are pretty spread out, but still close,
Right, yeah.
kind of. Then with 8, I do not understand how to figure out the shape of the distribution or I don't get how to do that.
So the shape would be if it's normal or normally distributed, or if it's approximately normal. And so
Or just be like the one in the picture, if it's a normally distributed one.
right, parent population is normally distributed. And so it said that the GMAT are normally distributed with a mean of 529. So then we can then assume that the parent population is normally distributed. So then the shape would be normal.
Okay. Wait, that makes sense. And so then the next one, the reason we know its shape is because it says that it's a normal distribution, right?
Right, and that the parent population is normally distributed.
So then what is the mean of the sampling distribution of sample mean scores for all such samples?
So if the mean,
What is it? Is that 529?
yeah, so if the mean's 529, then the sample means are 529.
Okay. And then the standard deviation of the distribution of sample mean scores for all such samples. Would that just be one?
So the standard deviation is, I slept on. How did I figure that out? I slept. It's like, what did I do? I didn't write it. Standard deviation is figured out by, this one is, where's my piece of paper here? Value minus the mean divided by the standard deviation. So it'd be the 529, is that right? Let's see here. Let me try to do this right. Now I don't remember how I did this.
What was the answer you got?
I got 35.734.
So you said is the value, or what was you say? Value divided by the mean, or times the mean?
Well, the standard deviation is, no, that's to figure out z-score. The standard deviation well, this is silly. What is the standard deviation? Distribution of sampling scores for all such samples. I cannot remember how to do this. And I can't find my work.
You said you got 30, what did you say you got 30?
35.734. All right, well.
That's okay.
Let me go look it up real fast here, see. This is the standard deviation divided by the square root of n.
Oh, okay.
So it's 113 divided by the square root of 10. So 35.734.
Okay. That makes sense. Okay.
All right, write that down so I don't forget it again.
Yeah. Standard deviation divided by the square root of the sample or of n.
Right.
Great. Cool. All right then. So now we can do the
Quiz.
quiz.
Yeah.
Okay.
We can try.
Okay, let me know when you're ready.
Okay, I'm ready.
Okay. When you are taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed? I don't know how you'd figure that out though. With only the information of the sample size.
Well, when you go to that that applet, when we're using that applet that it's talking about there, and you were doing that those examples, like all the means were to the left.
So would this still be skewed right? If the parent population is right skewed?
They would be that is a good question. They would be skewed.
How does the applet, how does that work though, of figuring this question out? Like what do we put in the area?
Because if all of your means are on your left, does that make it left skewed or right skewed?
I think it's right skewed.
Yeah, I'd go with that.
Okay.
If we get it wrong, we know we did it. We can change it.
Yeah. Yeah. But I don't get, see, so this next one though, when you're taking a sample size of 100, what is the shape of distribution means histogram when the parent population is right skewed? You know, I don't get
Well, it would.
the difference questions.
It would be 100. It would be normal because your sample size is large.
Oh. Okay, well that makes sense then.
That would be my guess.
No, I think that sounds right. Okay. So when you're taking a sample size of 5, what is the shape of the distribution of means histogram when the parent population is normally distributed?
And that would be normal.
Okay, yeah. Would the next one be normal too?
Yes.
So when would the distribution of means be normally distributed?
Sorry. I had that. There's normally distributed.
When the sample size is large? Or when the population that is normally distributed and the sample size is large? Wouldn't it be any time the sample size is large?
It down from 5 that is normally distributed samples. Yes. And drawn from a population is normally distributed and the sample size is small. And data drawn from a population that is right skewed and the sample size is large.
So the only one that it isn't is when it's right skewed and the sample size is small, right?
Right.
Okay. Okay. Which of the following gives the best explanation of the central limit theorem? Let's see. Would it be the last one? If the sample size is large, the shape of the distribution of sample means will be approximately normal.
I was just thinking. I think it's that the sample mean X bar will be close to the population mean.
Okay. Okay.
So
That seems right to me.
well, maybe, wait, hold on. The sample size shape of the distribution of sample means will. No, you might be right. If the sample size is large, the shape of the distribution of sample means will be approximately.
Yeah, even in the preparation key, actually, it says that the central limit theorem states that if the sample size is large, the sample mean will be approximately normally distributed.
I think you're right, yeah.
Okay. Let X be a random variable with a population mean of 10 and a population standard deviation of 6. Suppose a sample of size 36 is drawn from this population. What is the mean of the distribution of sample means?
Mean is 10.
Mm-hmm.
Standard deviation is 6.
Divided by, isn't the square root of 36 6?
Yeah, divided by the
Or
square
am
root.
I,
Yeah,
it's 1.
1.
Regardless of the distribution of the population, if the sample size is larger than 30, is large, what would be the shape distribution of the sample mean? Normal, right? Since
Yes.
it's large.
Yep.
And would that be the law of large numbers?
That would be the central limit theorem, right? If the sample size is large, the shape of the distribution
Yeah,
would be.
yeah, you're right. You're right. Okay. Let's see what we got. It's nice we have a second try on this too.
Yeah.
We got them all right.
Nice.
Awesome. Cool. Okay. I didn't do the preparation for number 7 for chapter 7. We can, if you want to get it over with, we can, and I'll just follow along, or we can meet again later with Bryce, whichever one, whatever you prefer.
I'm fine meeting later if you'd like.
Okay.
I could meet. I can meet on Thursday. I have a meeting on Wednesday already.
Okay.
Available.
Just want to do Thursday at the same time?
Yeah.
Thursday at 10?
What works? Oh, let me double check. I don't let me get in trouble here. Yes, I could do Thursday at 10.
Okay. Perfect. I will be there. Hopefully they're not planning on any other family emergencies. So
I hope not. That's,
yeah.
okay, so Thursday at 10.
Awesome.
This other one. All right, sounds
Okay.
good. We'll see you then. Thanks.
Okay, awesome. Bye.
Bye.